We're really excited to have everyone here today for our weekly OCI Deep Dive. For those of you who may be new to our events, we're hosted on Cloud Customer Connect, our Oracle community forums for end users. I'm Catherine Jennings, Senior Principal Product Manager with Observability and Management. And today we're joined with Murtaza Hussain, Director of Product Management, and German Viscuso, Director of Community Management, who will be taking us through Autonomous Database and all that means for observability and management. That is enough for me. Go ahead and take it away, German and Murtaza. German, please start and let me know when you're ready to launch your poll.
Okay, thank you, Catherine. So hello and welcome to this session about observability and management for autonomous database. I'm German Viscuso and I direct the developer community around autonomous databases with a strong focus on observability. So I have the pleasure to have Murtaza Hussain as co-speaker, who is fortunately a technologist, just like me. Murtaza is responsible for managing various cloud-native services within OCI's Observability and Management portfolio, such as database management and operations insights, which we will cover today. I also want to thank Cloud Customer Connect for giving us the space, obviously, so thank you, folks. So what is the purpose of this webinar? What we want is that you have a high-level understanding of the tools and services available to you to observe and manage autonomous databases. And this is thanks to Oracle's Observability and Management platform. That's why you have Murtaza here, of course. So after this session, you might want to go deeper into specific tools and services, and we are always open to listen to your feedback for upcoming sessions. So please feel free to reach out to us with suggestions. So let's go straight into the agenda, start the session with a high-level overview of autonomous database for those of you who are not so familiar with the service. Then Murtaza will cover the tools and services in the Observability and Management platform for autonomous databases specifically. And finally, I will go a bit deeper into metrics, events, and notifications in autonomous databases, which is a topic that I really, really like and I've been working on recently. So finally, we think we'll have enough time to do a Q&A and share a few key resources with you. Okay? All right, so let's go straight into autonomous database. So what is autonomous database? Why another database service? The idea is to leverage the Oracle Converge database for a simplified architecture and operational model. So Converge handles, you might be familiar with the Oracle Converge database. You know that it handles multiple data types and workload types, but gives you the same underlying architecture, which makes it easy for you to do the administration, the maintenance, the security, etc. So it's the same platform. Another important goal for ADB is to be fully managed and cloud native. We wanted to offer, and we are actually doing that, offering a self-service and pay-per-use model. This way, you can quickly be up and running and paying just for what you use, with the advantage of having extra data behind the curtains. You know, there's a very powerful extra data every time you create the simplest of autonomous databases, which is basically the most performant Oracle database tune hardware ever made, if you think about it, right? There's nothing better than extra data to run Oracle workloads. So finally, and this is the magic ingredient, right? We added machine learning to the mix, so you don't have to worry about tuning, scaling, securing, patching, et cetera, et cetera. I have a slide to cover that now. And this way, you don't have to spend time managing the database, and you can focus on actually building and deploying the applications, okay? So this is autonomous in a nutshell. So the strong focus on automation with, these inbuilt capabilities like auto-tuning, auto-scaling, auto-updating, auto-provisioning, auto-encryption, et cetera, makes it simple and easier to go to cloud because there's a lot of things that you don't have to worry about if you don't want to. And this is because this allows application developers to forget about all the tedious details of database management and focus on delivering the basically data-driven services. So I don't want to go into each one of these in detail, but the key takeaway here, if you are taking a look at these 10 things that we're doing automatically within autonomous database, is that each one of these are using enough intelligence to be the best choice for your workload. And if you think about autonomous database on dedicated Exadata infrastructure, we have two deployment types, serverless and dedicated. You think about dedicated, you get a lot of control over these automations. And to give you an example, for example, automatic patching, you can have a great deal of control here to comply with, for example, a specific corporate policies on how they must be applied, et cetera, et cetera. So it's not everything that is auto and you don't have any control. Basically, you also have a lot of control if you want to, okay? So to give you an understanding of the autonomous database stack, this is our resource model. So you can see that we go from the top all the way from the Exadata machine, and we go all the way to the database instances at the bottom. Some of you might be familiar with this because this is basically Oracle's pluggable database architecture. You might have heard about container databases and pluggable databases. So we're using this architecture. So this is obviously the Oracle pluggable database architecture. And as you can infer from this structure, observability is not only observing the database instance, but rather observing at multiple levels. For example, here you have containers, here you have autonomous VMs, AVM means autonomous VM cluster. So you might want an eye when you're observing autonomous database on different levels of the stack. And we think this is very, very important. This is ideal for autonomous dedicated because the customer owns the database stack, okay? All right. So for any cloud service, it's critical to fire events when the service is being operated, right? So ADB provides a full set of service API events, and examples are when you start a cloning operation, for example, or you want to know who started that cloning operation. Events are being fired, and this are just examples. We have much more, but there are also things that happen in the service as part of the life cycle of the database, and some of them are automatic operations. Like, for example, suppose a failover happens, right? So we also have events for these. But with an autonomous service, you need to change your mindset a little bit, and this is very important. So many things are being tuned and fixed behind the curtains for you. So you can and you should subscribe to our set of DevOps initiated events that you can see in the last major bullet points here in the slide. So these events could be like a DR replication that is stalled, a disk failure, etc. So you need to change your mind a little bit, where instead of monitoring the issues, you shift towards monitoring what Oracle, you also do that, to monitor what Oracle Ops is doing about those issues, okay? So this is very important, and this is available too. So I mentioned Oracle Ops working behind the curtains on behalf of our customers. We are bringing all our expertise and machine learning technology to do consolidated monitoring for the customer of the entire database stack, from the Exadata machine to the database instance. So automatic SRs are generating for deviations, and this includes root cause analysis for every issue. And even if you create an SR, this is very typical of customers, go ahead and create an SR, we have a faster response to these SRs thanks to all the contextual background information that is being gathered by the service automatically. Okay, so this is also very important. So when we combine all of this with Autonomous Data Guard, you might have heard of our DR solution. When you enable Autonomous Data Guard, you can have a 99.995 SLA guarantee, which is amazing and basically translates into zero downtime, close to zero downtime. All right, so this session is about observability, and you have seen that in the title already, and many people correlate that to directly to database monitoring. So they say database observability, database monitoring the database. But this is only just a part of database observability. Database observability is an ongoing cycle where telemetry is collected first, for example, performance metrics, maybe CPU utilization, you name it, then processed as part of the database monitoring, like, for example, the OCI monitoring service, which we will cover this later. Then some internal processes are also being analyzed, for example, query analysis is one excellent example. And finally, there's a tuning step, where this could be done either automatically by the service, or you might also jump in and do some tuning by yourself. And this cycle helps to progressively fine-tune the database. So this happens in a constant cycle that maintains and improves the database operation. And as I mentioned before, and as you can see here in the graphic, I just animated the slide, so you can see that for managed services like Autonomous, Oracle also takes part in this observability cycle with the potential to react and act on anomalous situations like we mentioned before. So this could be happening automatically behind the curtain without your intervention. All right, so I'm going to transfer now to Murtaza. Murtaza, you can take it away. I'm going to stop sharing, and then I will come back. Thank you.
All right, gentlemen, thank you so much for the introduction and introduction to Autonomous Database. At this point, I will dive into OCI overview from observability and management point of view. So before I do that, I just want to launch a quick poll in terms of understanding the interests or understanding of the services more from observability and management point of view.
It's been launched, Murtaza. Just give it a minute.
Okay, thanks, Catherine.
Looks like a fair majority are aware of it, but would like more information. We have a good mix of people looking for more additional. And the same with the database management and operations.
Okay. All right. So yeah, so we are here to kind of talk about that. So let's get started. I think there's a healthy participation, about 70%. So, all right. Okay, so I wanted to give you guys a quick overview of what we have in observability management services, right? So basically, if you look at this, right, observability starts from the core services, which is the OCI infrastructure services that entails compute, storage, database, network, and security. On top of that, we have built some telemetry services, telemetry types, such as what we call MELTs, which is metric, events, logs, and traces. And now recently we have added SQL, and which is used in terms of basically giving important information around your services and what you're building on top of that from observability management point of view. And we also use these services to build our what we call our advanced services within observability management, which is application performance monitoring, stack monitoring, logging analytics, database management, and capacity planning and SQL Insight, which is part of Operation Insights. Right. All right. So today, for our webinar today, we are mainly focusing on what we have for observability management platform from database management point of view. We divide this platform into 3 different cloud native services. One is database management platform, which provides a unified console for on-premises and cloud databases with capabilities for monitoring, performance management, tuning, administration, and mainly matching to what Oracle Enterprise Manager offers, with some caveats as this is growing service within OCI. Now, anything beyond immediate monitoring and for long-term analysis, we rely on Operation Insights, which you see in the middle, providing essentially, it provides capacity planning, forecasting based on over 2 years worth of data, right? It can store up to 2 years worth of data for that analysis, right? It also helps do consolidation resources in your enterprise, as well as prevent any unexpected resource-related use outages or any performance issues pertaining to your databases. Finally, any discussion on database management doesn't end without a discussion around logs. So for this, we have logging analytics, which is a separate service which allows you to ingest all sorts of logs, such as alert, attention, network logs, or any other sort of application log to see the larger view of environment's health and drill down to specific logs when needing to investigate performance issues. Just want to give you a quick view of how our landing page looks. This is within Oracle Cloud Portal. Within Oracle Cloud Portal, if you click on the hamburger menu at the left-hand side, you go to Observability Management, Within that, you can see our suite of services, which we offer within observability management. Today, we'll be kind of talking about more about database management, operation insights, and logging analytics, but we have other services that complement these services. All right. So in terms of key observability features for autonomous database, currently OCI console or OCI suite of services natively support monitoring and management of autonomous database. So from a metrics perspective, you can use OCI monitoring service to ingest autonomous database related metrics to diagnose and troubleshoot problems. You can also create alarms on key metrics based on certain thresholds, and those are adjustable. Similarly, you can also use another service, which is called OCI events, that can be used to kind of look at and understand the state of events that are changing across your autonomous databases, right? For example, if you're creating, terminating, backup, doing any backup operation on autonomous database, you can use OCI event and notification service to get informed about that, right? And then what we're going to be talking about from observability and management point of view, we have a database management service, which offers performance tuning tools, well known to you guys from Oracle Enterprise Manager point of view, right? Which is Performance Hub, and then lets you kind of look at kind of like a fleet-wide view of a database enabled across your workload, right? Whether it's on-prem, cloud, autonomous databases, everything you can view in a fleet-wide view, and you can manage them from a single pane of glass using a database management service. You can also look at some of the performance metrics around DB time, average active sessions for those databases within a fleet view, or you can also drill down into individual databases for that matter and look at what's happening at that level. All right. Lastly, what we have and we will be talking about is the capacity planning and SQL Insights. This is part of what we call our Operations Insights service. This is a long-term telemetry service which ingests telemetry data, observability telemetry data around your workload, whether it's host, databases, or anything, and basically give you a capability of forecasting around CPU storage, memory demand, and also lets you look at some of the SQL performance-related insights across your workload, including for autonomous databases. Okay, in terms of autonomous database metrics, we just mentioned, right, we have this service which is called, if you can see on the right-hand side, this is the OCI monitoring service. And within OCI monitoring service, a user can literally come in and select the compartment and the metric namespace for the autonomous database. And they can start using different dimensions to start building their widgets, which can then be translated into respective dashboards if need be, right? So we're talking about very useful metrics in terms of autonomous databases such as CPU and storage utilization, SQL execution, and transactions. They can also slice and dice data for autonomous database by key dimensions, such as autonomous DB type. If you're looking at autonomous database from a warehouse perspective or more from an ATP, autonomous transaction processing, right? You can also further slice and dice data by deployment type, whether it's based on serverless or dedicated, and that can also help in doing your analysis. I do want to mention here that, with the dedicated, you get the whole stack, right? Meaning in terms of analysis, you can look at the Exadata machine, the VM clusters, and the CDBs, BDBs running on it, like German explained it in his one of his slides, right? So it's the full stack, which is controllable and can be analyzed. All right, from database management perspective, right? So it's this one again. I want to give a quick overview. It's an on-demand cloud-based subscription service that is natively available in OCI as a managed service. It combines the backend instrumentation and tools that are already available with Oracle database kernel itself, and you have a rich visualization-driven interface which allows you to have single pane of glass management for databases, including autonomous databases that are either deployed on cloud or on premise. And in terms of what we can do is you can look at the fleet view, right? So right now what we're looking at is the performance view within autonomous databases. What you can see on the left-hand side, and on the right-hand side, you can see the cloud and on-prem databases onboarded onto database management service. So from the fleet management page within database management service, you can drill down into individual database, right, of your choice. In this case, we're looking at autonomous data warehouse shared. We can pretty much look at some of the metadata, important metadata around the database. You can also look at the availability timeline in terms of how the database has been doing based on the time period selected. Right now, we're looking at last 60 minutes. You can look up to last 7 days worth of data from availability timeline perspective. Down below, we have some performance metrics around average active session divided based on the CPU threads and the wait times. And you also get access to activity charts, storage, SQL statements, and failed connection metrics around your database. So if you're familiar with Enterprise Manager, you likely have seen the Performance Hub before. You can obtain access to real-time monitoring utilizing Ash Analytics, SQL session details with information regarding blocking sessions. You can get historic views can also be adjusted for long-term performance investigation. There's a time picker window here. You can adjust that and look at the analysis you want to do within that time range. You can also launch other services features like ADDM on-demand reports, SQL tuning advisor tasks against specific queries, or more in-depth SQL investigation with SQL Warehouse. So there's a lot of drill down which is available within the Performance Hub. You can use different applications like Ash Analytics, SQL monitoring, ADDM blocking session. You can also go utilize some of other complementary services which are available, such as Operation Insights using the Performance Hub. So this is, again, within Performance Hub, we have this application, which is real-time SQL monitoring. It allows in-depth application performance analysis. We can get data around a single SQL, around the metadata around that, how the SQL has been behaving over the selected period, what plans it has used, how many plans it has used, what was the last refresh cycle, and so on. And then you can also get some performance metrics around time and wait time and IO buffer gets. And if you see down below, we can also see how this SQL has been behaving from plan statistics point of view, right? How each step it has been executing and how much time it has taken. It kind of gives you an interactive view of the visualization of the plan around the SQL. Similarly, within Performance Hub, a user can also go into blocking sessions, which gives you in-depth application weight analysis. Essentially, it kind of gives you a breakdown of each session by SQL ID, by user session, gives you the actual SQL ID, the wait event, the object name, blocking time, and so on. Gives you detailed information around that. It lets you also inspect and drill down into the SQL involved by using the hyperlinks provided here, and also lets you perform operations like kill operations in one or more of the listed sessions to resolve any waiting session problem. All right, switching over to our next service within Operation Insights, which is Operation Insights service. So in this, basically, service, this is a long-term telemetry service, as I mentioned, right? It lets you store about 2 years worth of data and allows you to do effective capacity planning, right? So in order to do capacity planning for databases hosts, we can use the application, which is called capacity planning within Operation Insights. So things like as a fleet administrator or database administrator, it can let you do use case goals such as at the compartment level, both at the CPU level and storage level. You can see, how your database has been doing historically and how you can use that information to do forecast in the future, right? And for forecasting purposes, we have built in different forecasting models, which you can utilize to do a forecast based on varied workloads. This is another application within Operation Insights. It's called SQL Performance, essentially SQL Warehouse. So using the Oracle SQL Warehouse function, you can analyze the SQL performance problems of enterprise-wide applications across a fleet of databases, right? In addition, it provides trends and key insights to SQL performance issues, thereby helping you to be proactive in avoiding future problems. So you can look at here, right? It provides you a tree map by different performance measures. You can look at it by CPU time or any other performance measure which is available through these drop downs, and you can quickly figure out which SQL is the problem statement within your workload, right? From there, you can drill down into individual SQLs, look at by different dimensions, and further use other tools and services which are available within SQL Warehouse to further analyze your problem statement. Right. I do want to mention that recently we have enhanced this SQL Warehouse application with a new application which is up and coming, which is called SQL Insights, which essentially ingests SQL stats data at a fleet level, database and SQL level, and provides you that context in the form of 3 dashboards, so to speak, right? So we have a fleet level dashboard, which is called fleet analysis. We have database level dashboard, which is DB analysis, and then we have a SQL level dashboard. All these dashboards are interconnected, and then you can literally drill down from a fleet level dashboard to a database level dashboard, and from there you can select a SQL of your choice and go to a SQL level analysis dashboard. Yeah, this is the view of how it can look in one of the dashboards within SQL Insights application. So within Operation Insights, we offer this warehouse capability, which is called AWR Hub, which is essentially it's taking all the AWR data from your database, source databases, and then storing it in an autonomous database within Operations Insights tenancy. As you can see from the top, the data is ETL from database sources into OCI object storage, and from there it is ETL to autonomous database. This is similar to what we had in Enterprise Manager, which is AWR Hub, which is AWR Warehouse. Essentially, it is the cloud-native solution for AWR Warehouse. Some of the key use cases are listed here, such as performance analysis, pre- and post-consolidation, other custom use cases, and other analytics on system-level data. Onboarding of this is very simple in this cloud-based AWR Hub solution. So right now it's available for autonomous database. You can utilize this for your performance-led analysis based on AWR Hub data. This is another application which is built within AWR Hub functionality, which is called AWR Explorer, which lets you look at the AWR data from a different perspective. It literally lets you explore some of the dimensions, performance dimensions, such as the ASH dimensions around wait times and different metrics, and let you build different charts around that. All right. As we talked about earlier, we also have this solution service, which is called Logging Analytics as part of Observability Management. It lets you analyze application and audit logs. Essentially, you can adjust any type of logs to visualize data based on that log data, right? And helps you in getting greater insights from those log data. You can also analyze and do searches on that log data. And then also you can save those searches and then utilize that for your future analysis. Logging Analytics also provides capability of creating new dashboards, widgets, and then dashboards out of the log data, which you can also utilize for your analysis. It also provides you out-of-the-box dashboards, which you can utilize for different sources, including database and autonomous database. So just want to quickly highlight in terms of log analytics, right? Some of the use cases for DBS can be utilizing out-of-the-box deep Oracle it comes up with this out-of-the-box dashboards, right, which utilizes deep knowledge of Oracle databases, and it really helps you in terms of troubleshooting the issues, performance issues, and other issues around your Oracle databases, right? So what it does is it ingests all the log data automatically and classifies them into commonly known used error categories, and then you can search and explore those logs using familiar error categories, right? And then, as I mentioned, right, it has out-of-the-box dashboards specifically for Oracle databases, including autonomous database. Those dashboards are mainly around audit logs, alert logs. You can also have out-of-the-box dashboards around listener logs dashboard, which helps you in looking at what's happening around your listener from a life cycle perspective. All right, to wrap it up, we pretty much covered all these areas in terms of what we can do around autonomous database and what features are supported in Oracle Cloud. So if you see on the left-hand side, we have the functionalities which we covered, which is around OCI monitoring. We have database metrics, autonomous database that can be utilized for exposing and setting alarms on key metrics. You can use OCI event service for notification and also connect that with PagerDuty, Slack, and other third-party tools, ITSM tools. Germany will talk in depth about database metrics, OCI monitoring, and OCI event service shortly. In terms of database management, we talked about the fleet view, we talked about single DB resource page, we talked about the capabilities with what database management offers around Performance Hub, and some of the other tools which are associated with Performance Hub, which are listed over here. We talked about Operation Insights in terms of capacity planning, forecasting, SQL Warehouse, SQL Insights in terms of looking at problem SQLs around your workload. And lastly, we also touched upon AWR Hub, which is a warehouse offered within Operation Insights and looking at database performance analytics. And then lastly, we touched upon logging analytics in terms of ingesting audit logs, error logs, other types of logs, database logs into logging analytics service, and then utilizing some of the out-of-the-box dashboards to further triage those problems. All right, at this point, I'll hand it over to German to educate us further on ADB-related metrics and look at some of the stuff around OCI events and OCI monitoring.
Okay, thank you. So Murtaza briefly covered the ADB metrics, and here is a list of metrics that a autonomous database dedicated is exporting specifically to the OCI monitoring service, which also was mentioned by Murtaza. So they usually do a 1 minute interval for these metrics that you can see here. If you take a closer look, you will see that they can go pretty deep, covering storage metrics and DR-related metrics. We keep adding and expanding on the metrics, and we export them to the OCI monitoring service, which is a key service, basically aggregating metrics and telemetry for every single OCI service. So there's a short link in the top right if you are interested on how to monitor autonomous databases specifically with OCI provided tools and services. All right, so here's an example of the autonomous data guard metrics coming straight from the console. But you know that you should know that you can also access these via APIs or set thresholds and get notified. Okay, so here you can see apply lag, transport lag, etc., etc. This is DR specific and specific to autonomous data guard. So in order to do this, the OCI monitoring service is ideal because of its tight integration with all the Oracle database services, because of its ability to set up alarms and having them trigger via notification or streams, as you can see here on the right, and also because the aggregated metrics are accessible for multiple channels, like for example, via the console, via APIs, via SDKs, you name it. So it's basically the fact that the system is living within OCI, it doesn't mean that it doesn't interact with third-party services, with external services, etc. So it's very open. One common use case is setting up alarms on specific database metrics. You configure a topic and then connect that topic to a specific notification channel, as Murtaza already mentioned, like Slack, for example. So, and here you can see in the slide that you have obviously other options. You can do email, SMS, you can do pager duty, you can even call a function. I'll cover that in a couple of slides. So I'm going to walk you through the creation of a simple alarm, but I will use screenshots that I have in my slides, so I'm not going to do this live. But if you want a more advanced demo, please take a look at the session in the short link in the top right, because that's the session that we did with the EMEA specialists recently, where we have real working demos in order for you to take a look at this. Okay, so just follow that link and you will see this in action. All right, so when you're looking at an autonomous database instance in the OCI console, in the bottom left, you will see a set of resources. One of them is metrics, as you can see here. So when you click on it, you'll see several tables with different or more graphics, right, with different metrics. If we go to the CPU utilization box, for example, and click on the options combo box, we'll find the option to set up an alarm, as you can see here. Create an alarm on this query. We'll then get an alarm definition screen where we can configure the details of the alarm, not only the alarm text itself, like the body here, but also the criticality of the event, the interval of the polling that you want to do, and the type of a statistic for threshold. You might want to do a min, a max, the mean value, etc., etc., etc. Then we have to define the most important part, which is the trigger rule to define when to trigger the alarm. Okay, so here in this example, you can see that we are doing greater than with a value of 80, and then you can also define a trigger delay in minutes. You can obviously add additional dimensions, right? But this is just for the sake of showing a very simple example. Now we configure the topic. You might be familiar, maybe if you use Kafka before, or if you use MQTT, etc., you might be familiar with how to set up topics to get notifications. I might want to get an SMS, for example, when this alarm fires, maybe a Slack too, and I might want to call a cloud function to trigger my own custom processing. So here, you can define the type of subscription, and you are up and running. Sec. Okay, so you can, of course, see the fire alarms in the console. As you can see here, there's access to detailed alarm history. So it's not only that you will get them in your defined subscription channels, but also you can come to the console and see what fired here, right? So again, if you want to see this in action, don't miss the session in the short link in this page, because we set this up in that session and we make it work, okay? All right, so I mentioned events when I covered the autonomous database stack. I said that we are firing events at multiple levels of the stack, and that is very interesting if you want to keep a close eye on the whole stack, not only on the database instances. So an event basically informs of a resource state change. Autonomous database dedicated events can be classified as control plane events and data plane events. The control plane events are events that are generated via the use of public APIs by the customer, such as, for example, starting a backup, to give you an example. On the other hand, the data plane events are events that were triggered within the database or on the host due to some sort of issue happening, such as, for example, an automatic failover because of a primary failure. to give you another example. So you can also use these events to trigger some type of action. So this is not something that can happen with metrics and setting, specific alarms with specific thresholds, etc. But you can also react to these events. For example, they can also be integrated with third-party services like Slack, PagerDuty, etc., etc. So we also have that functionality, and these are specific events that are firing natively in the database. You can create topics in your tenancy that can consume these events. I'm going to to give you a quick level walkthrough. But again, if you want to see this live, you should take a look at the session in the top right. This is the same session that I mentioned for metrics. The fact is that in that session, we cover both things, events and metrics. And that's a hands-on demo. All right. So after setting the topic, as I showed you in the previous slide, you can set up rules on specific events. In this case, you're looking at an autonomous VM cluster begin event. So we are saying, okay, when the VM cluster begins its operation, I'm going to do something about it. This event is going to trigger, I'm going to catch this event, and I'm going to do something about it. So the rule allows you to define an action, and here you can select the topic you created before. This decoupling is nice, and I think it's really nice because you might want to add an extra channel to the topic. Like, for example, you might want to add Slack because you did not have Slack before, and you don't even have to touch the rule. Basically, you can go to the topic and do that, right? So this decoupling makes things interesting and more maintainable. In this case, where we are calling the topic Ops Watcher, okay? So cloud functions, as I mentioned before, are also targets in the actions of the rule. So just like metrics, you can trigger a custom function to do your own processing then when the event fires. So for those of you that are not familiar with functions, these are basically pieces of code that run within the OCI cloud, and you have several languages to choose from, and basically they will run on demand. And it's very common that in any cloud service you basically pay for them when the functions are running. Okay, but they give you great flexibility because you can basically connect to whatever you want. You can do custom processing within the function. You can call another service from the function that is not natively supported, etc., etc., etc. All right. So events are JSON, as you can see here. So this makes it easier to parse them in the case you want to manipulate them, right? Suppose that you want to send the event to a third-party service, and you want to basically parse, and basically, modularize it and turn it into different segments, et cetera, you can do that because this is just plain JSON. And the good thing about the Observability and Management platform is that it's a standard space. So it's really good to see the use of open telemetry there, et cetera, et cetera. So things are not difficult for the typical, observability developer. Okay, so we are basically done here. So we can go to a Q&A round, or I don't know, Catherine, if you want.
Yeah, I'm going to go ahead and launch the last poll as well, but
okay, go ahead.
We didn't have too many questions throughout the Q&A. Just one was more on pricing. So I don't know if you or Murtaza want to re-hit any of the items you've already discussed, or we can certainly keep the Q&A open if someone does have questions. Feel free to raise your hand or go ahead and ask in the Q&A.
I think that while we wait for, please go ahead and put your questions there. If there's another one, we can take it now. But maybe Murtaza, you can clarify a little bit of the pricing for the OEM services?
Yeah, so each of these services, right, what we talked about today from observability and management point of view, we have different SKUs pertaining to different applications which are needed, right, within each service. So for example, for database management service, for autonomous databases, we have a separate SKU, right, and that is charged at OCPU per hour. Right.
Okay.
Similarly, for Operation Insights, we have multiple SKUs depending on the database flavor. And if you're interested in AWR Hub, the warehouse, we have separate SKUs for warehouse.
Okay.
Yeah, that's how it is. And for logging analytics, I believe it's ingest-based SKUs, depending on the amount of log you're ingesting per GB, right? So you basically charge at that rate. All this information can be accessed through observability management. Within that, I can share the URL where you can see the pricing for all the services we talked about.
Yeah, I can post those back into the chat as well. And
that's great.
if you have questions on where to access the information, you can subscribe to the Cloud Customer Connect events, or you can certainly reach out to us with individual questions.
Okay. I want to say something about pricing on Autonomous. So the good thing about Autonomous is that this is basically a pay-per-use service, right? So, for example, suppose that you deployed a serverless Autonomous database, and you are only paying for it when the database is running. So the database is stopped, and you are not paying for any kind of stack that is sitting there or anything like that. So this is basically what I like, and a lot of our customers are using that to basically reduce TCO, total cost of ownership. So yeah, just wanted to clarify that. Is there any other question?
We do have a question. Someone's looking for some differences between observability and stack monitoring.
Yeah, I think that I briefly covered that when I showed the, let me just go back to that slide 1 sec, because we still have time. Just give me 1 sec.
Sure, we have time.
Here, yeah, because we have some time now, so we can have the luxury of doing this. When I went through this, right, I basically said that if we consider only database monitoring here, we are basically looking at one of the 4 pillars that you can see here to do database observability. We are monitoring the database. That's right. But what about all the telemetry collection? How is telemetry generated? How is it collected? What services are behind the telemetry collection, like the OCI monitoring service, for example? What about all the steps that we want to do when it comes to analyzing internal elements of the database? So for example, we might want to tune queries, right? Murtaza spoke about SQL monitoring, for example, and how we can optimize it. And that is also part of the database tuning step, because we might want to proactively, try to step in and do something about the database and try to basically make it better than what it was before. And so this is difference, in my opinion, about between monitoring and observability. When it comes to the stack specifically, and we're talking about the whole stack, you can monitor the stack, but you can also observe the stack in the sense that you might want to use standard observability tools with this stack, right? So monitoring you might do with one or one service, or maybe what you used to. But if you want to do like proper observability, you might want to maybe connect those events to other type of dashboards. You might want to connect it to Grafana too. For example, I know that Murtaza, you've worked with Grafana before in terms of supporting it within OCI. So this is basically, depend on what you really want to do and what your observability needs are. Sometimes companies have specific processes for observability, and they have specific tools that they want to use, etc. So in my opinion, in my view, and I've been working a lot with observability, what is database observability is, for me, it's enabling customers to actually use tools and services that they've been using, that they are familiar with, but basically augment them with any OCI services that we have there to basically create a whole observability solution for them. Okay.
Yeah, I just want to add over there, if you're talking about stack monitoring, we do have a service specifically, named stack monitoring. It essentially proactively looks at the application and its underlying application stack, right, including application servers and databases.
Yes.
So
APM,
that can be,
right?
Yeah. So no, there's a stack monitoring service.
Okay.
Yeah, and then there is, from a performance perspective, we have application performance monitoring, right? That's an APM service. That's also part of observability management, right? That's purely looking at how the user behavior has been, across the application stack, starting from the web browser and all the way back to the backend database service, right? So that's APM service. So we have these two services. If you're interested, you can look into these stack monitoring and APM.
And this opens up a very interesting discussion, which is I have done a few sessions called Unified Observability, and I was referring to Unified Observability because you might not want to do to have a clear difference between you don't want to use different tools for database observability and for application performance monitoring, for example, and you might want to go from a specific issue that is happening within the application all the way to something that's happening behind the curtains in the database, right? And that's part of tracing. You can do tracing of a specific span, for example, and you can go from the front end of the application all the way to the database. And that is something that I have been trying to cover on several sessions called Unified Observability. And I think that is super interesting because there seems to be a mismatch right now into the tools being used to do specifically database monitoring and to do maybe application monitoring dashboards, right? Or monitoring. That's a very interesting topic.
And also just to add to that, right? So we are actively, as we speak, working for making sure that we have a natural complementary interconnectivity between these services. So to make sure that the user gets an Uber experience when they basically utilize our suite of services within observability and management. So we are working on, we're making an intelligent connection between these services as much as possible.
That's very clever. In my opinion, that's very clever, and that's going to be extremely useful. All right. Is there any other?
No, there are no more questions. So I just want to thank you, German and Murtaza, as well as Sriram, PB, and Dave manning the Q&A. And thank you all for your attendance. We'll be posting this session, the session information, either later today or tomorrow. Have a great rest of your day.
Okay. Thank you, folks, all of you.
Thanks all.